Hello everyone, welcome to my channel. This is Jacob. Welcome to the Linux Cafe, and this is day 4 of our C programming course. So I supposed to record this video the previous week, but due to a war, uh, actually I didn't have the possibility to continue recording because the internet connection was awful, so it was limited to people, so I didn't have access to internet connection, and also I didn't have the chance to record day 4. So here we go. In this video we're going to talk about data types in C and type specifiers in C. So we're recording, yes. Okay, so let me just increase the size. I'm going to open a tmux for myself, splitting, and okay, let's open the directory that we're working in. So there's no directory. Let me just remove this app.c, open it again so it's fresh. I'm going to include the header file stdio.h and the main function. Now, throughout the course we learned how a C programming is structured, and you also learned about how functions work. I told you that the main function is the entry point of a C program, and I also told you that how a C code must be written in a function and not actually outside of a function. If you write a function outside, if you write a statement, a line of code outside of a function, so it's not going to compile. You're going to have compilation error. So now it's about data types. I also talked about printf and scanf. Let me just change the color scheme quickly. Industry is good. So you learned about printf and scanf, two functions. Scanf is for scanning something. It means it's used for actually taking input from the user, and also printf for printing out to stdout, which is our terminal. So let's talk about data types. Actually, in C we have many data types. We have some group of data types which I'm going to talk about. In C we have 4 types, 4 main categories for the types. So the first is, we can say, the basic types, or we can call them primary, the primary types. The second one is derived data types. Derived data types, sorry. The third is enumeration data types. Actually, that's about the enum keyword. So call them how can I write enumeration? Oh yes, it's like enumeration. Enumeration data types. And also, I think that's all. But I think we can also separate void itself. Void. So these are the 4 data types that we have in C, these 4 categories. So in this video we're going to talk about all of them, but I'm just going to show you examples of the basic types and also void. For derived data types we are going to have separate videos for each concept of it. So basic or primary data types, actually these are the fundamental types used to declare variables in C. So types that are used to declare variables in C. My shift has a problem, I don't know. That's weird. I recently bought this keyboard. Okay, types that are used to declare variables in C are called basic data types. So we have many of them. What does that mean? It means we have many types that are used to declare variables in C. Simply, we have char. I'm going to write the main, main ones. So we have char, we have int, we have, for example, short, we have long, we have long, we have float, and also double. And also we can have some sort of long double, okay? Long double. So each actually data type here has a different size. You know, it can hold data with different sizes, but that's actually platform independent. But for example, an 8664, architecture system, for example, like, um, I mean, for example, Linux that I'm using currently, uh, no, it's not specific, special. It's not a special hardware device. For example, it's not a STM32. Um, it's not a Raspberry Pi. It's not a, for example, cheap. So that's my system. Okay, it's a normal, typical PC personal computer that we're using right now, and it's running a Linux. So here I'm going to talk about, for example, the sizes that each variable can handle, but that's platform independent. Don't forget it. For example, a system. For example, I'm a POS programmer. If you know, uh, POS, point of sales devices used for doing transactions in different stores that you go buy something. You use your credit card on a POS device. So for example, on a POS device, an int can be 4 bits as an example, okay? So that's platform independent. These are platform if I'm writing correct, I think I should write platform dependent. Yes, dependent. It depends on platform. Sorry, let me fix my word. It's platform dependent, not independent. My bad. Okay, so these are platform dependent. Now about the size. Typically, a char takes 1 byte. Okay, it's 1 byte. A word, one word is 2 bytes. If you see, for example, in textbooks, they write that, for example, a word. So you must know that it's 2 bytes. We also, for example, have wchar. It's a system data type. It's a word byte. You know, it's 2 bytes actually. So 1 byte. Char is 1 byte or 8 bits. And int is 32 bits. 32 bits, or for example 4 bytes. A short is I guess it was 2 bytes, yes, or simply we can say 16 bits. 2 bytes, 16 bits. So it's 16 bits. A long is 32 or 64 bits. You know, actually it's dependent on the data you're saving. Actually, you can use a long instead of an int. Okay, instead of writing long int, you can simply write long, like int age. 23 or long 23, this is actually the same as long int. Okay, so these are the same. These two are the same. Int is actually 32 bits, but or for example, simply we can say it's 4 bytes, but a long can be also 64 bits, which means 8 bytes. Okay, so if you are, for example, dealing with larger numbers, you're going to use a long. If it's not a, too much big number, you're going to use int, and if that's a very small number, you're going to probably you're going to use a short. For example, I don't know, say a number. For example, age is a short number. Okay, for age, you're free to use a short instead of an int. For example, short attempts. Okay, attempts. It can be, for example, 10. That's a short. Now we have long, which is 64 bits or 8 bytes. We can have long. For example, I don't know. No, not pi. Not the p not the p number actually. For example, it can be, I don't know. It can be, I don't know. Actually, I don't know what big number to say as example. For example, the distance between moon and planet Earth can be a long, I don't know. Okay, so let's stop saying examples. Okay, you will understand which one to use throughout the course and while you're writing code yourself. So we have float. So long was are we recording? Yes. So as I told you, long is 4 or 8 bytes. Okay, we do have long, so that forces it to be 8 bytes. And also we have float. Oh, I wrote float. We have float, which is actually 4 bytes. 4 bytes. It's used for floating point numbers, like for example 2.5, okay, or 12.75, I don't know. I have double, which is actually larger than float. It's 64 bits or 8 bytes. It is 64 bits or 8 bytes. We also have the long double, which is much larger. It's between 10 to 16 bytes actually, I think. It's about 10 to 16 bytes. So you're not going to memorize these sizes, okay? But if you memorize, it's just alright. But you're not. It's not a force, okay? Everyone knows that an int is 32 bits or 4 bytes, okay? Now, what are type specifiers? For example, oh, I wish I wouldn't delete this one at least. So, for example, I say int age is 23. Okay. Now I'm going to use printf to print it down. I can simply say age true. Let's see if we can. gcc app.c, boom. So it says expected const_char something blah blah. But argument is of type int. So because your argument is not of type char, okay, so look at here. If I give it a char, what do you think will happen? We still have problems. By the way, expected is of type int, format not a string. So here it forces you to actually use type specifiers. So what does that mean? It means that here I want to print 23. So I'm simply going to say, sorry, my bad actually, I should use double quotes for this. Okay, now we have a. I don't have to use single quotes. So here I can simply say, for example, age. So I'm here I'm forced to use a type specifier, because in C it's not like, I don't know, Python or Java, you know. If you let me, you see, format not a string with row and no format arguments. Okay, so I cannot concat these two, so I'm forced to use a type specifier. It means I'm just going to say comma separate, comma space, okay, age, and age is type int, as you can see here. So the type specifier for an int is either %d or %i. Okay, %d. So \n for the new line, saving, recompiling, and you can see that my age is 23. By the way, I'm 21. My birthday was June. Happy birthday to me. Okay, let it go. No senses. By the way, so %d or %i is used for an integer. As you can see, I can also use %i. And for example, for a long number like this, okay, let's say printf %d again. Let's see what will happen. Number. So it says format %d expects argument of type int. Okay, but argument 2 has type long int. So you can see here that it says long int, which means that I've shortly written, you know, long number, but for the compiler it's the same as long int. So if I actually write long int, there's no difference between long and long int. Okay, so here I must just use %ld, so it's a long decimal. Okay, I can just say like this, and now I can have my output. You see, so we have different type of specifiers for different types. For example, for a float number, I can say, for example, float pi. Okay, where am I? Okay, the pi is %f \n. If I just say %d, sorry, pi, it says actually, so format %d expects argument of type int. So, but that's a warning, that's not an error, so I can just compile it. I can run it, so you can see that pi is not pi. So you must use %f for a float. So %f, sorry, rf. I can say gcc app.c again, and if I run it, I can see my actually p number 3.1415 and 00. But why 00? Because per default it shows the 6 numbers after the period. So here we can say just 0. That's this is the syntax used. I can say 0. I can say what was it called? 0.2. So here I have 3.14, or I can, for example, say 0.4. So I'm saying that I need the 4 numbers after the point. The fourth actually number of my floating point number. So if I just write it, and if we compile it again, we can see our number. Easy. Well, this is about floats, and also that's the same with doubles. Okay, now I have a doubt. Let me check something here. Actually, for double you can use LF, I guess. The LF is the long float. So for double, just simply use LF, like the LD that you used for the long. Uh, that's it. But %f also works. But while using a scanf for a double, you must specify it as LF, not F. But for printf, %f is commonly used for both floats and double, because the float is promoted to double while printing it out. Well, so as an example, I want to show you something else about the size of function. Size of int in bytes, okay? I was checking my notes. I understood that I also have to talk about the size of function for you. So here, as you can see, the ZU, I'm using the this type specifier to see the bytes of the actually int data type. So the size of it is showing that it's 4 bytes. So now if I use it for, I don't know, long, that's 8 bytes, okay? So also you can use the size of function to check. Also, we use the size of function for many purposes, which I'll be showing you in a few future videos. So this is about types, and also we have signed and unsigned keywords, which I will talk about it in the next video. So what are derived data types? As I told you, I'm going to record videos for them separately. So derived data types are actually arrays. So arrays are a collection of elements of same type. Pointers, for example, the second one is pointer. Pointers are actually for storing memory addresses of another variable, which you're going to learn and you're going to understand deeply, because it's very important in C. We have structures, which are collections of variables of different types. We also have unions, which is the same as struct, but all members share memory, which is an advanced concept. We also have functions, a block of code with, I don't know, return type or no return type. So functions are also counted as data types, derived data types, not primary data types, okay? So that's it. We also have enumeration, as I told you. We have the enum keyword, which we will have different videos for it. And also we have void. As I told you, if something is void, it's not going to return something. Void is used for functions. So thanks for watching this video. I'm not going to take it too long. In the next video we're going to talk about more things. So also another thing I'm going to show you is, if I show you the ASCII table, for example, I don't know, number number, I don't know, 60 for example, 60. So here is why a type specifier is important. For example, now if age is 60, and here if I say printf %c of age, okay, you can see this one easily, because I'm saying that I want the %c, or actually the character of number 60, which on the ASCII table it's pointing to this character. So that's it. If I, for example, print the %c of number 77, I'm going to have M. And yeah, I wanted to show you this one. So thanks for watching this video. In the next video we're going to talk about derived data types. We're going to start with, let me check, we're going to start with arrays, and after arrays we're going to talk about pointers. So thanks for watching the day 4, and see you in the next video.